Welcome back. We're going to talk today about the dot product of two vectors, which is some sort of product. We've learned how to add two vectors, how to scale vectors, and now we're going to learn, in fact, two different ways of multiplying two vectors together, the dot product of two vectors and the cross product of two vectors. Now, why the dot product? You have to keep your eye on the goal. Do you remember what our goal was? We set up a goal the first day. Anyone remembers what am I trying to do with vectors? Tangent planes. We're trying to find the tangent plane to graphs, but for that I actually have to tell you what are how to even define a plane, and we said we're going to define planes by what we call their normal vector. If I have a point and a normal vector, a vector that is perpendicular to the plane, that defines a plane. So what do I need to know? Actually, so if this little line I drew here, if I extend it so it's a vector that is in the direction of the plane, I can tell if two vectors are perpendicular if I can measure angles. Okay, so what we need now is to know what is the angle between two vectors. So if I have a vector and some other vector, they're going to describe an angle. Even in space, any two vectors in space, you can throw a plane through them, and then it's a plane, and there's two vectors, and there's going to be an angle that is described by the two vectors, and I want to compute that angle. And I want to compute that angle because I want to know when they are perpendicular, or what we'll say orthogonal. So we need, first of all, to know how to compute what's the angle between two vectors. And that is exactly what the dot product is going to do for us. How the dot product is actually, how does it come about? Let me give you one very quick idea of what this is. Why do we have the dot product in the first place? So if we have two lines, if this line is a slope m, what is a line? What's the slope of the perpendicular line? If one line has slope m, what's the line of the perpendicular line?
-1 over m.
The slope that I'm looking for is -1 over m. So let's look for a vector in the direction of this line. If I go m units and 1 up, this vector has so I want to go, what do I want to go? If the slope is going to be m, we want rise over run, right? So I want m here and 1 over here. There. Okay, so this is slope. This vector here, the vector m1 has a slope m. And now if I want a vector that has a slope -1 over m, I want rise of -1 and a run of m. So how about if I do -1 comma m? So that vector will have a -1 m will be perpendicular. So these two are what we call perpendicular. And you can see that if I multiply them like it's indicated here, so m, if I multiply this coordinate with this coordinate, times -1 plus 1 times m, I get 0. So it's from that idea, in fact, that the dot product is defined, that is going to tell us this dot product is going to be 0 exactly when two vectors are 0. So in any case, what is the dot product? If I have two vectors, a and b, the dot product is going to be a number. It's a number, it's not another vector. That will be the cross product. The dot product is just a number, and it is denoted by a little dot from the name dot product. A dot b is going to be the sum of the product of the coordinates. And you can see here that if I do the sum of the product of the coordinates of those two vectors that we know are perpendicular, I do get 0. So that's actually the feature we're looking for in the definition of the dot product. So let me just work it out in a couple cases. So what is the dot product of A and B? I just do the sum of the product of the coordinates, so it's 1 times 2 plus 0 times 3. So that is 2 plus 0, so it is 2. And remember that this is going to tell us if it is 0, then the vectors are perpendicular. The number is 2, so they're not perpendicular. We'll give a meaning to the number anyways in a moment, but this is how you compute dot product. Let's see what is the dot product of A and B in this case. So 1, 0, minus 1, dot. Just to distinguish from regular multiplication, my dot in dot product is going to be a very thick dot. Is the sum of the product of the coordinates. So it's 1 times 2 plus 0 times 5 plus minus 1 times 2. That is 2 plus 0 minus 2, so I get 0. And that is going to be key for us. That's going to tell me that those two vectors are perpendicular in space. So as I said, the key property of the dot product is that two vectors, if you have that the dot product is 0, that is true if and only if A and B are perpendicular. We say perpendicular or orthogonal. Okay. There is a curious recording. There is some case in the Supreme Court a few years ago where one of the people defending the case, they were talking about some issue, and then they were starting to talk about some other issue, and the attorney said, oh, like, well, but these two issues are orthogonal to each other. And I forget, I think it was Scalia, Justice Scalia, that's like, they are what? And then they had all this discussion about what orthogonal meant. So now you know. Okay. So this is the key property that we really like about the dot product, is that it tells me when two vectors are perpendicular, which is what I want for finding normal vectors to planes. But it actually tells us a lot more. So one very nice thing that it tells us is that two vectors are perpendicular if their dot product is 0, but in fact it tells me the angle. It turns out that if the angle between the two vectors is theta, so that means that I have an angle, I have u, I have v, and the angle that they describe is theta, it turns out that there is this beautiful formula that tells me that the dot product of the two vectors is the length of u times the length of v times the cosine of the angle. This formula, this other formula, this fact actually comes from Pythagoras' theorem. This fact right here comes from what's called the law of cosines in trigonometry. So one can figure out that these two things are related. The angle and the dot product are related, where again, these bars indicate the length of the vectors. But sometimes we like this just to explain what the dot product is, but once you see that the angle is there, we might as well just single out the angle and give me a formula for the angle. So what that formula is equivalent to is this one, that the cosine of theta is given by this formula. So I don't know you, but finding cosines between two lines, what's the angle between two vectors, that seems a little bit complicated. And this is just all algebraic. This is just an algebraic equation, and then the square root of the lengths. Those are some algebraic equations, and then I can find out what the angle is between two vectors. So let's try that. What's the angle between the two vectors? 1, 0, minus 1, and 2, 5, 2. Let's repeat the formula. What is the cosine of the angle? Is, in this case, with a's and b's, I have to compute the dot product and divide it by the length of A times the length of B. You see the difference in dots? That is the dot product. That's just multiplying two real numbers. Okay? So I need to compute a few things. So let's start with the length of A. The length of A will be the square root of 1 squared plus 0 squared plus minus 1 squared. Is that too small? Is that good? So this is what? This is the square root of 2. What is the length of B? The length of B will be the square root of 2 squared plus 5 squared plus 2 squared. So that is 25 and 429 and 433. Is that so? Okay. Did I need to do all that? Maybe not, because what is the dot product? We had done that before. The dot product of the two vectors is going to be 1 times 2 plus 0 times 5 plus minus 1 times 2, which gives me 2 minus 2, so I get 0. So that tells me if I put all my information in the formula for the cosine is that it's 0 divided by, unless I have zeros underneath, this is going to be 0. And I do not have zeros for lengths. You don't want to compute the length or the angle with the 0 vector. There is no angle. So they have to be non-zero vectors to begin with. So this is 0. What angle has cosine of 0? Pi over 2. Thank you for giving me an angle in radians. That's 90 degrees, but we prefer radians over here. So that tells me that A and B are perpendicular because the angle is 90. Okay. By the way, just remember, if you have trouble, remember, I trying to figure out what are all the values of the trigonometric values at common angles. Just remember that if I start in a unit circle, so if the circle is of radius 1, and this is theta, this point here has coordinates cosine theta, sine theta, which is actually how you should define cosine and sine. Okay, so this length here is cosine theta, and this length here is sine theta. So if you're at 90, then you are here, and the cosine, the x-coordinate, is 0. So the cosine of 90 is 0, and that's the angle we were looking for. It could have been that the angle is, like 3 pi over 2, or not more. Like, how much is this one? 270, right? But that means that I just flipped my vectors. If two vectors are at 90 degrees, then if I consider from here to here, or if I flip them, they would be at 270 degrees if I measure the other way. So same difference. They're perpendicular. Okay, or if you know what the domain is for arc cosine, we measure in a certain domain so that there is no repetitions, and the answer is uniquely pi over 2. All right, so let's see what happens, though, if I want to compute the angle between these two vectors. Let's start again. I'm going to write again the formula. I have to do the dot product. and divide by the product of the lengths. Let's not do that again like we did in the previous slide. Let's do the dot product first, just in case it's just 0 and I don't have to compute lengths. So what is the dot product? 1, 1, 0, and I'm going to dot with the square root of 3 over 2, square root of 3 over 2, comma 1. And that is the square root of 3 over 2, or 1 times the square root of 3 over 2, plus 1 times the square root of 3 over 2, plus 0. So it's twice the square root of 3 over 2. Just going to leave it like that for now. Okay. What is the length of A? We saw that the length of A, that length is the square root of 1 squared plus 1 squared, so the square root of 2. And the length of B will be the square root of, luckily the square of the square root is the number itself, so this is 3/2 plus 3/2 plus the square of 1. That is 3/2 and 3/2 is 3 plus 1 is 4, a square root of 4 is 2. Fantastic. So now I can figure out what the cosine of the angle is. The dot product is twice the square root of 3 over 2. And then I have the length of A times the length of B. The 2's are going to cancel out. And what I get is the square root of 3 over 2 divided by the square root of 2. Or if you simplify that, that is going to be the square root of 3 divided by 2. What angle has cosine the square root of 3 over 2? Pi over 6. Very good. Thank you so much. Which is in degrees. It's what angle? 180 divided by 6. So this is 30 degrees. So these two vectors are at 30 degrees in space. And that's how you compute an angle. So that is my answer, is that they are at pi over 6 angle. All right, let's give you a quiz. Are the vectors 2i plus 2j minus k and 5i minus 4j plus 2k perpendicular? All right. So in response to, are those even vectors? Remember that we can write vectors in terms of the standard basis vectors I, j, and k. So those are the vectors 2, 2 minus 1, and 5 minus 4, 2 in coordinates. Or we can do it in terms of I, j, and k. So let's see what happened. So are those two perpendicular? I can do the dot product directly with these vectors. So if I want to do the dot product with vectors in this form, then I do the sum of the product of the coordinates. So it will be 2 times 5 plus 2 times minus 4 plus minus 1 times 2. And that is 10 minus 8 minus 2, and I get 0. So yes, they are perpendicular. They are orthogonal. Okay? All right. So any questions?